Ever wondered why your code doesn't work as expected even though it appears to be perfect? Welcome to the fascinating world of programming, where things aren't always what they seem. Let's delve into some of the common misconceptions that programmers often encounter while writing code. These misconceptions can often lead us down the wrong path, causing confusion and yes, those pesky errors that keep us up at night. In this tutorial, we're going to debunk some of these myths and misconceptions. We'll explore why more lines of code don't necessarily mean more efficiency, and why programming isn't just about coding. We'll also discuss how all programming languages aren't created equal, and why debugging is far from a waste of time. So, are you ready to clear up some confusion and get a stronger grasp on the realities of programming? Great! Time to dive in and unlock the mysteries of programming. First stop, the misconception that more lines of code equate to more efficiency. In the grand scheme of programming, this notion couldn't be further from the truth. It's often tempting to equate length with depth, to think that a thicker book holds more wisdom, or a longer movie, more entertainment. But when it comes to coding, this line of thinking falls apart. You see, in coding, brevity is king. The fewer lines you can use to accomplish a task, the better. This doesn't mean we should aim for cryptic, unreadable code. On the contrary, we should strive for code that's concise, yet clear and easy to understand. Code that does exactly what it needs to do, no more, no less. Consider two chefs. One uses 100 ingredients to cook a meal, the other uses just 10. The first chef's dish might be complex, but it's also likely to be overwhelming, confusing, even off-putting. The second chef, however, carefully selects each ingredient for maximum impact. The result is a dish that's simple, yet full of flavor. In this analogy, the second chef is the better coder. In programming, every line of code is a potential point of failure. More lines mean more places for bugs to hide. They mean more complexity, which makes code harder to understand and maintain. They can also mean slower execution times. In contrast, concise code is easier to debug, easier to read, and often faster to run. Let's imagine a scenario where we need to write a function that calculates the factorial of a number. One might write a lengthy code with multiple loops, condition checks, and temporary variables. However, the same result can be achieved with just a single line of code using a recursive function. So, the next time you find yourself writing a long, complex piece of code, ask yourself, could this be simpler? Could this be clearer? Remember, your code isn't just for machines, it's for people too. It's for you when you come back to it 6 months from now. It's for other developers who might need to understand and modify it. Remember, efficient code is not about quantity, but quality. Keep this in mind and you'll be well on your way to becoming a better, more efficient programmer. Scene script. Time to tackle the second myth. Programming is all about coding. Let's dive right in, shall we? When someone says, programming, what's the first thing that pops into your head? For many, it's a screen filled with complex lines of code. While coding is certainly a significant part of programming, it's not the whole story, not even close. Imagine programming as a journey. Coding is like the car that gets you from point A to point B. But before you can even start the car, you need to know your destination. This is where understanding the problem domain comes in. It's about identifying what you're trying to achieve, the challenges you might face, and the best route to take. Just like you wouldn't embark on a road trip without a map, you wouldn't start coding without a clear understanding of the problem at hand. Now let's talk about problem solving. Once you're on your journey, there are bound to be roadblocks. Maybe there's a detour, or perhaps your car breaks down. You'll need to think on your feet, adapt, and find solutions. Similarly, in programming, you'll encounter bugs and issues that need fixing. You may even need to rethink your entire approach. It's all part of the process. Another crucial aspect of programming is logical thinking. It's about breaking down complex problems into manageable parts, just like how you would navigate through a busy city. You wouldn't try to take in the entire city at once. Instead, you'd focus on one street at a time. In programming, you decompose problems, tackle them piece by piece, and gradually build your solution. So, you see, coding is just one aspect of programming. It's like the car in our journey analogy. It's essential, yes, but it's not the only thing that matters. You need to understand the problem domain, have problem-solving skills, and think logically. And let's not forget about testing, debugging, and maintaining the code, but that's a topic for another time. Coding is just a part of the whole programming process, not the entirety. Scene script. Moving on to the third myth. All programming languages are the same. Well, let's tackle this misconception head-on. Imagine, if you will, an artist's studio filled with a variety of tools, each with a unique purpose and function. There's a chisel for carving, brushes for painting, pencils for sketching. Now, could the artist use a chisel to sketch or a brush to carve? Probably, but it would be incredibly difficult. And the end result likely wouldn't be as good as if they used the right tool for the job. The same concept applies to programming languages. Each programming language, like an artist's tool, has its unique features and strengths, optimized for certain types of tasks. Some languages are designed to be simple and easy to learn, making them perfect for beginners. Others are complex and powerful, designed to handle large-scale projects or specific tasks like data analysis or web development. For instance, Python is often praised for its simplicity and readability, making it a popular choice for beginners. It's also widely used in data science due to its powerful libraries for data analysis and manipulation. On the other hand, JavaScript, while having a steeper learning curve, is the backbone of modern web development, allowing you to create interactive and dynamic websites. Then we have languages like C and C++, known for their speed and control over system resources, making them ideal for system programming and game development. And let's not forget about Java, a versatile language used in everything from web applications to Android app development. The point here is that each programming language was designed with a specific purpose in mind and excels in certain areas. So, when you're starting a new project, it's important to consider what you're trying to accomplish and choose the right language for the job. Just as an artist wouldn't use a chisel to sketch, you wouldn't want to use Python for system programming or C++ for a simple web app. The right tool, or in this case the right language, can make all the difference in the efficiency and success of your project. Different languages, different strengths, choose wisely. Now let's debunk the fourth myth. Debugging is a waste of time. This misconception is a classic one. Some developers might see debugging as a tedious, time-consuming process. They might think, why spend hours or even days hunting down a single bug when I could be writing brand new, exciting code? But the truth is, without debugging, your code is like a car without brakes. Sure, it might run, but it's probably not safe and definitely not efficient. Imagine this. You've written a lengthy piece of software, it's beautiful, it's elegant, you've poured hours into it, but then you run it and something's off. It's not working as expected. Do you just shrug and move on, leaving the problem to fester and potentially become a bigger issue down the line? Or do you take the time to investigate, to get to the root of the problem and fix it? The latter, of course. That's what debugging is all about. Debugging is like the detective work of coding. It's about understanding what's going wrong and why. It helps you to dive deep into your code, to understand not just the what, but the why and the how. It's a learning process that will make you a better programmer. Let's take an example. Consider a software that's crashing unexpectedly. If you don't debug, you might ignore a memory leak that's causing the crash. But if you debug, you'll not only fix the crash, but also improve the overall performance by fixing the memory leak. Debugging also improves the quality of your code. It helps you to identify and eliminate redundant or unnecessary parts of your code, making it cleaner, more efficient, and easier to maintain. So, is debugging really a waste of time? No, it's an essential part of programming. It's a process that helps you to understand your code better, improves the quality and efficiency of your code, and makes you a better programmer. Debugging is not a waste of time, but an investment in better code. So, we've debunked some common programming misconceptions today. We've seen that writing more lines of code doesn't necessarily mean more efficiency. Instead, the quality of your code, its readability, and its maintainability are what truly matter. We've also established that programming is not just about coding. It encompasses problem-solving, logical thinking, and design principles. So don't limit yourselves to just writing code. We've also acknowledged that all programming languages are not the same. Each has its own strengths, weaknesses, and ideal use cases. It's crucial to choose the right tool for the job. And lastly, we've underscored the importance of debugging in the coding process. It's not a waste of time. Rather, it's an essential step in ensuring the quality of your code and learning from your mistakes. Keep these points in mind the next time you're coding, and you'll be on your way to becoming a more effective programmer. Until next time, happy coding.